All right, let's dive right in. Deep beneath the surface of our rivers and lakes, there's this hidden world, and it's home to some of the most important critters you've probably never even thought about. They're absolutely essential for the health of our water. But here's the thing, they are incredibly hard to find, let alone count, especially when the water gets all murky.
So that's the central question, right? It's what researchers have been struggling with for years. If you can't even see these animals, how on earth are you supposed to know if their populations are doing okay or if they're in serious trouble? Well, it turns out the answer might just lie with some seriously clever AI.
So who are these mysterious creatures we're talking about? They're freshwater mussels. And trust me, they're not just some boring lumps on the riverbed. They are a critical, I mean critical, part of the entire aquatic ecosystem.
And these mussels, they do a ton of work. Think of them as nature's little water purifiers. They're constantly filtering out gunk and pollutants, which makes the water clearer for all the other plants and animals. They're also what we call bioindicators, which is just a fancy way of saying their health is a direct mirror of the river's health. So if the mussels are thriving, the whole ecosystem is likely thriving too. Long story short, we really need to keep an eye on them.
Okay, and that brings us to the big challenge. Even though they're so important, actually monitoring them is a massive headache. You can't just, peer into the water and start counting. It's way more complicated than that.
Let's just compare the old ways with the new. For years, scientists had to rely on manual surveys, and I mean literally sending divers down to feel around by hand. It's slow, it's expensive, and it's totally useless if the water is too deep or cloudy. The other option is acoustic sonar, which is great because it can see through that murkiness. But, and it's a big but, the images it kicks out are often a noisy, blurry, pixelated mess. It's like trying to recognize your friend in a terrible low-res security camera photo. You just can't get an accurate count.
But this is where things get really cool. A team of researchers from the University of Tokyo knew there had to be a better way. For their study at Lake Izunuma in Japan, they developed a totally groundbreaking solution, one that combines high-tech sonar with the raw power of artificial intelligence.
They call it the Sonar Speedy Scanner, or Sonar SS for short. What it is a high-frequency acoustic camera mounted on a small boat that gets these super detailed pictures of the lake bed. But the real magic, the secret sauce, isn't just the camera. It's the two specialized AI models they built to make sense of all that data.
So let me introduce you to this AI power couple. First up, you've got Mamba AR. I like to call this one the image enhancer. Its entire job is to take those fuzzy, low-quality sonar pictures and, like magic, reconstruct them into sharp, clear images. Then, once the image is all cleaned up, it gets passed to Mussel YOLO, the expert spotter. This is an object detection AI that's been trained to do one thing and one thing only: find and identify every single mussel in that picture with incredible accuracy.
So, you're probably wondering how this whole system actually works together, right? The sonar, the two AIs, let's break it down. It's actually a pretty elegant process. First, the boat zips around the lake, and the Sonar S system scans the bottom, grabbing all that raw acoustic data. Next, those raw, kind of blurry images are fed straight to Mamba IR, the image enhancer. Step 3, the now crystal clear images are sent over to Mussel YOLO, our expert spotter, which goes through and finds all the mussels. And finally, the system takes all of that identified data and turns it into a super detailed and accurate map of where all the mussels are.
And this right here, this shows you the problem perfectly. Take a look. This is what a standard sonar image looks like without any AI help. Could you confidently spot a mussel in that blobby mess? Yeah, me neither. This is exactly the challenge that Mamba IR was designed to crush.
Okay, now get ready for the wow moment. Compare that blurry image on the left to the Mamba IR version on the right. I mean, the difference is just night and day, isn't it? It's literally that sci-fi movie moment, where they shout, "Enhance!" at the computer screen, except this is real. Suddenly you can see the detail, the texture, the sharp edges. It's all there.
Seeing it is one thing, but how much better is this new system, really? Let's get into the numbers, because the results are frankly even more impressive than the pictures.
This table really says it all. The old methods with those blurry images could only find the mussels with about 60% accuracy. That means they were missing almost half of them. But with the new Mamba IR method, that accuracy number jumps to a massive 91.4%. That's not just an improvement, that is a total game changer.
Let's just let that number sit there for a second. 91.4%. That's the level of precision we can now get counting these vital creatures in water so murky you can't even see your own hand. It's incredible.
And if you're wondering how the AI actually thinks or sees, this visualization gives us a peek under the hood. It's a heat map that shows us exactly what Mussel YOLO is focusing on. Those bright red spots, that's where the AI is most confident it's found a mussel. It's not just guessing, it's learned to zero in on the exact features that matter.
So we know it's way more accurate. But is it faster? Oh yeah. This quote from the research paper is just stunning. This new system can survey about 1,400 square meters an hour. That is over 100 times more efficient than the old-school diving surveys. Work that used to take weeks of painstaking labor can now be done in a few hours.
So, what's the big picture here? What does all this add up to? Well, this technology basically unlocks a whole new world for conservation. We can get faster, cheaper, and way more accurate data. We can now monitor places that were completely off-limits before. And this tech isn't just for mussels. It can be adapted to track other things, like nasty invasive species, or even to see how our ecosystems are holding up against climate change. It's a seriously powerful new tool in our toolbox.
And this leaves us with a really fascinating thought to end on. We've just figured out a way to see one specific, hidden part of our world. But this is just the beginning. It really makes you wonder, doesn't it? What other environmental secrets are out there, just waiting beneath the surface, that new technology like this could finally help us uncover?